right, we've made it here to number 4. Again, we're following the order of operations, so back to PEMDAS. We're going to look inside the parentheses to see if there's operations we can perform. I look inside, everything's already together. I look inside, everything's already together. I'm going to go to exponents next. I see that both of these expressions are raised to a power, so I need to take this and multiply it in. Don't forget that if there is not an exponent, go ahead and get that 1 there so you don't forget to put that exponent with everybody. So I now have 3 to the 4th power, x to the 12th power, y to the 4th power, minus, I have 7 to the 2nd power, x to the 10th power, and y to the 2nd power. I'm going to go ahead and bring down my multiply by x squared, y squared. So let's look here. I have some subtraction, I have some multiplication, but I also have these coefficients that are raised to a power, and they're not the same power, so at this point I'm going to go ahead and multiply those out so that I don't have to worry about those exponents anymore. So 3 to the 4th, well, that's like 3 times 3, which is 9. It's really like 9 times 9. So if you think that through, that is 81, x to the 12th, y to the 4th, minus, well, 7 squared is 49, 10 to the 2nd, y to the 2nd, times x squared, y squared. Order of operations. Do I subtract or multiply? Yeah, I should multiply. So I'm going to keep the 81 x squared y to the 4th. And this is going to be negative 49 times, remember that's just a 1, so 49 times 1 is 49. The x to the 10th, x to the 2nd. Keep the base, add the exponents for multiplying. So that would be 12. I have y and y, so I'm going to get that y. They're both a 2, so when I add 2 plus 2, I now have 4. Oh, I just realized I didn't write that, so I'm going to get that 12 there. Now, I'm looking at this and I'm like, oh, I have subtraction. Okay, now if I have subtraction, remember this is just like terms, so I'm going to add or subtract the coefficients. So 81 minus 49. Now remember, this only works if they're alike. These are alike. X to the 12th, y to the 4th, and x to the 12th, y to the 4th are alike, so I can add or subtract them. What is 81 minus 49? Well, that looks like 32. And then we keep the variables exactly as they were. We do not change them when we are combining like terms.